is on. So go ahead and turn the page. I want to kind of give you the math. And we'll go from there. So what I want to do is I'm going to work through Dodge City together. And then I'm going to give you your analemma, and we'll work on a couple other things, and then that should get us out of here. We're going to talk about what is called, and by the way, I am horrible about, like, things can be called like 3 different words in the English language, and I'm horrible about interchanging them. So if you're not sure what I'm talking about, just ask. I'm going to talk about what, if I was smart and put it in basic terms, I would simply say it's the noon sun angle. Because that makes perfect sense. Those are 3 words everybody can handle. But I'm not. And so sometimes it may say angle of solar inclination, angle of solar declination. It all means the same thing. It all means the noon sun angle. And by noon, I don't mean right this second on that clock there noon. I mean sun's highest point in the sky throughout the day. I'm talking noon local mean solar time based on the sun, not based on our time zone manipulation. So here's the ground. Here's Mr. Sun. Here's you. Because we're little compared to Mr. Sun, right? All right, if you go out at noon, local mean solar time, you find the sun, and you point your hand out like that. That angle would be your noon sun angle. So if you were to go out at noon, and the sun's on the horizon, and in some places this can happen. You're going out at noon and the sun's on the horizon, that would be 0 degrees. If you were to go out at noon and the sun is straight over your head, that would be 90 degrees. For every place else, it's going to be somewhere in between. Now, is it ever going to be more than 90 degrees? No, you would just see it in the other sky. Does that make sense? Like you'd be looking towards the south sky if for some reason that would just mean you were looking the other way. So if you drew a line, this is your noon angle. Can I make the little just angle symbol for angle? That's good. Because I don't spell very well, and I once wrote an entire report on the killer angles, which was fine, except the book was called The Killer Angels. I want you to flip over, and I want you to look at where it says noon sun angle. I'm going to make you do these, like I'm going to make you do the math on your own. What I'm going to do is walk you through an example using a different latitude. The first step, and it's okay to do these on a notebook so you have the notes. I know I didn't give you enough room. I know I didn't give you lots of room, but make sure you kind of go through the, if you want my help ever, you got to go through, you got to do it my way. Otherwise you're on your own. The first thing I do is I draw my Earth. Now, the tilt in this case doesn't really matter, so you don't need the tilt. So I'm going to draw my Earth, and I'm going to draw the equator there. Now, are there certain times of the year when you know exactly where the sun is directly overhead? What I did yesterday, what I did yesterday. Is the sun ever directly overhead at the equator? On what days of the year? The equator is directly overhead on the what? Equinox, right? Both fall and spring. So on the fall equinox and spring equinox, or on my paper I just said equinox because it doesn't matter. The sun is directly overhead at the equator. Where is the sun overhead at on the summer solstice? Is this as far north as the sun is directly overhead at? Like that line, that Tropic of Cancer line, right? Or 23.5 degrees north. So on the summer solstice, you already know that the sun is directly overhead at 23.5 degrees north. That means on the winter solstice, the sun is directly overhead at 23.5 south. All right. So I'm going to come up with a fictitious latitude. I'm going to, what was your latitude? 50 degrees? Something like that? 55? Are you an X? Let's do that now. Let's go 52. Let's do it. Yeah, I do remember that. Hey. Our latitude in Dodge City, Kansas is 37.75 degrees. That's what's it. So I'm going to work out some examples. When you do this on your own, you're going to substitute 52 degrees with 37.75. But the math stays the same. All right, here's what you do. The first thing you do is make a mark for your latitude. We're going to say 52 degrees north latitude. That's where she lives, roughly. Okay. Then, for each day, you're going to make a mark. For each one, you make a mark where the sun is directly overhead at. Okay, I say, where is the sun? The sun's 150 million kilometers out there, but what I'm really asking is, where is the sun? What latitude will the sun be directly overhead at? That's what I'm really asking. All right, on the equinox, where is the sun directly overhead at? On the equator, right? The sun's directly overhead here. All right. This isn't really a formula, like a math formula, like quadratic equation formula. This is more of a thought process formula. Okay? So I'm going to kind of show you how I get it right in my mind. The reason I'm going to make you draw this is if you want my help, because you got to get a visual, because this is kind of hard to wrap your head around without a visual. So my thought process is 90, because do you have any other options besides 0 to 90 for latitudes? There's 0 to 90 north, 0 to 90 south, but those are our options, right? 90 minus, and I use the symbol delta, the Greek letter delta. It just means change in, difference between, change in latitude, equals noon sun angle, but I'm just going to write sun angle. Because the noon, we're just assuming it's the noon. I mean, if it's at the sunrise, it'd be 0. Now let me explain what I mean by change in latitude. What I mean by change in latitude is the number of degrees difference between where you are and where the sun is directly overhead. So in this case, the sun is at 0, you're at 52. How many degrees are here? 0 is a nice, easy number to work with, so it's 52 degrees. So my change in latitude is 52 degrees. So if I want to know my noon sun angle on the equinox, where she lives, I would say 90 minus 52 equals, and 90 minus 52 is 38 degrees. So I'm talking spring, fallish where you're from, okay? If you went outside at noonish and you looked at the sun, this is 0, this is 90, this would be 45. So would that be, if you followed your hand out, clear out for 150 million kilometers, would that be about where the sun would appear in the sky? In the spring, fall, like Marchish. That one's easy because we use 0. Let's do this. This stuff all stays the same. Yeah. But what do I have first? Summer solstice. Where is the sun at on the summer solstice? Where is the sun, where is the sun directly overhead at on the summer solstice? Yeah, I'm not telling you because I did 5 seconds ago. What? No. Where is the sun? What latitude is the sun directly overhead at on the summer solstice? Where does the sun go to and from throughout the year? Does it ever get up here? So where's the sun? On the equinox it's here. Is it here on the solstice? What? Yeah, so it's 23.5 degrees north or south. Because we're doing everything for the northern hemisphere. Because we're biased that way. All right, so now I'll put a mark here, 23.5. Okay, that's now, what is my change in latitude now? How many degrees between 23.5 and 52? We use these, right? 28.5, are we okay with that? All you gotta do, if you and the sun are in the same hemisphere, you just subtract the two numbers, right? You subtract the two numbers. So, now, I have 90 minus 28.5 equals 90 minus 61.5 degrees. So in the summertime, sun would probably be somewhere out there. You fall out your hands. It's going to be higher in the sky, right? Let's do winter. Where is the sun at on the winter solstice? Going to be 23.5 south, right? What is my change in latitude if you're here and Mr. Sun's clear down here? Now what's the change in latitude? Now what do you do with these two numbers? You got 52 degrees here, right? And then you got to go another 23, so 62, 72, 75.5. And 90 minus what, 14.5 degrees? Man, in the wintertime, your sun's real low in the sky, isn't it? And do you notice that? Like what you experience here, it should seem, it's enough of a change for you guys. It's a noticeable difference. It freaked me out when I went to a river, but for you guys, it was, you know, a little brighter than